Hey everybody, so this is the very last thing that we're going to do for the stoichiometry section is to look at how to calculate percent yield in a chemical reaction. And we actually did percent yield way back at the beginning of the year, so it's kind of coming back now. So usually one of the last questions you'll be asked in these stoichiometry problems is what is the percent yield of a certain product that you're going to make. And in this case, they're asking about this product here, this sodium nitrate. We're going off the same chemical equation as we did in the stoichiometry problem. So same one. So in this particular example, we're being asked, what's the percent yield of this sodium nitrate when we react the 30 grams of the ammonium nitrate with the 50 grams of the sodium phosphate? And they're telling us here, when we've done this experiment, we've made 25.2 grams of sodium nitrate. So they're asking us to compare our theoretical yield. What did we calculate we were supposed to get of sodium nitrate? Compare that with what we actually got of sodium nitrate. So whenever you do an experiment, you'll have an actual yield, how much you actually made. And you can compare that with what you should have made if you did the calculations out. So in order to tackle this problem, to figure out the percent yield, you need to first identify the limiting reactant. In this particular example, we already did that. We identified that the ammonium nitrate was a limiting reactant, and you can see the previous video to figure out, to see how we figured that out. So, but if you haven't done that already, you first have to identify the limiting reactant. So you first have to figure out which one of these reactants is going to give me the least amount of this particular product that we picked. And again, we identified that already. That was the ammonium nitrate. Then what we do is we calculate the amount of product produced by the limiting reactant, and that's the theoretical yield. And again, we already calculated that in the previous video. So this ammonium nitrate will give us, theoretically, 31.45 grams of sodium nitrate. This is mathematically what we should get. If you notice, this number, this theoretical yield, is different than the actual yield. And as I mentioned before, that's normal. There's many different reasons for that. The purity of these particular reactants. Maybe you didn't scrape all of the sodium nitrate out of whatever container you were using. There's many different reasons why you're not going to get the theoretical amount that you should get. So the last piece of this then is to calculate a percent yield from the theoretical yield and the actual yield. And that's really easy to do. You've already identified the limiting reactant. You've already, at this point, figured out what the theoretical yield is. So the percent yield formula is just you take the actual yield and you divide it by the theoretical yield. And then to get a percent, you multiply by 100. So this is what we actually got, according to the number they've given us here. And we're dividing it by what we should have got, which is the 31.45 grams. Multiply that number by 100, and you get 80.12%. So what this number means is that this reaction had an 80.12% success rate. And obviously, you want this number to be as big as possible. The closer to 100, the more successful the reaction was. The more pure your materials were, and the less sloppy you were in your experiment. So you want this number to be high. There is a sheet that goes along with this, a practice sheet. I'm going to do a couple of them with you, just so that you can get a feel for how these work. This particular example was pretty quick because we had already identified the limiting reactant. We had already identified our theoretical yield from the previous presentation. So that's why this was so quick. But you'll see on the practice problem sheet, it's not going to be as quick because we have to first figure out the theoretical yield. So stay tuned for that video.